Okay, we are in Unit 6, and this is kind of a review that I often give in class before the test. So I'm not sure when I'll do this in our classroom. We have, I think we have a couple of review days. So I'll probably do this one day in the classroom. So I'm beginning with just some integration. So we have some antiderivatives and we have some definite integrals here. So let's take a look at what we would do for number 1. For number 1, I'm looking at the denominator, and I'm going to treat this denominator as a single thing. So I'm treating that as my u, all right? So I'm doing a u substitution where u is 3x squared minus 5. So I'm going to take the derivative of each side, so I'm taking the differential. Du is equal to 6x dx. Okay, and remember that we're substituting. So I see over here I have the x dx. So here's an x dx and there's an x dx. So if I move the 6 over, I'd have 1/6 du is equal to x dx. So in place, I'm substituting. So in place of the 3x squared minus 5, I'm putting a u. And in place of the x dx, I'm putting a 1/6 du. 1/6 du like that. So 2 times a sixth is 1/3, and I'm going to move that 1/3 outside the integral. So I will have 1/3 times the integral of, and now all I have inside is du over u, or 1 over u du. And the antiderivative of 1 over u du is natural log absolute value u plus c. Last up, go back to x's. Okay, these are going to be multiple choice questions, and the choices will be common mistakes that I have seen. So be careful and don't make any of those mistakes. All right, let's take a look at number 2. A good rule of thumb is when you see an integral that has a natural log in it, if it has a natural log in it, natural log x, if it has that in it, try to see what would happen if you let u be that. So I'm going to come in here and I'm going to let u be natural log x. So u is equal to natural log x. Du is the derivative of natural log x is 1 over x. And you can think of it as moving the dx over. So du is 1 over x dx. Do we have that in the problem? Well, yeah, we do. We have 1 over x dx, right? So in place of that, in place of 1 over x dx, I'm going to put du. So now I have du on top, and on the bottom I just have u cubed. So this is 1 over u cubed du. How do we find the antiderivative of that? This is not a natural log because u cubed is on the bottom, not just u. So when we have that, we move the u to the top and use the power rule. Really, you guys, all we have so far is the power rule and this u substitution. Really, we do. We know some of the trig antiderivatives as well, but really that's all we've got in our toolbox so far. We will get some more, but so far that's all we have. Okay, so we use the power rule, add 1 to the exponent, divide by that exponent, plus c. So now I'm going to go back to my x's. You could write this as -1/2 times natural log x to the -2 plus c. That's probably not what they would have as that's probably not what they would have as a multiple choice answer. They would probably move, since it's a -2 exponent, they would probably move it to the bottom, and they would make it -1 over 2 times natural log x all squared plus c. That's probably the multiple choice answer. Okay, next up, a definite integral, but we still begin by finding the antiderivative as per the fundamental theorem of calculus, right? So again, I'm looking in the denominator, and there's my u. And I know when I take the derivative of this, I'm going to get a sign. And a sign is sitting right up there. Okay? So there's my u. U is equal to 2 plus cosine x. Du is negative sine x dx. So here's a sine x. Here's a sine x dx. Here's a sine x dx. What do I put in place of sine x dx? A negative du. A negative because we would need to bring that negative over, and we're doing a substitution. We're substituting. Okay? So now we're going to have the integral, the antiderivative of negative, which I'm going to pull outside, negative du over u, or 1 over u du. Now, I'm not going to put the 0 and the pi over 2 here. Why not? Because 0 and pi over 2 are x values. I know they are x values because of this dx. I have a u now. So I need u boundaries now. They're not hard to get. Just go and put pi over 2 in for x to get the u value there. Cosine of pi over 2 is 0. 2 plus 0 is 2. So 2 is my new upper boundary. We go to our lower boundary. Cosine of 0 is 1. 2 plus 1 is 3. So our new lower boundary is 3. And now I notice that my upper boundary is lower than my lower boundary, so I need to flip those. Before I go any further, I flip them and I change the sign. So now it's a positive integral. Take the antiderivative, natural log absolute value of u. Okay, common mistake I see kids make. They put the 2 and the 3 here, and then I see them go back to x's. Go back to x's. Well, why is that a mistake? It's a mistake because you're about to put in the 3 and the 2, and you're not going to put in the 3 and the 2 for x's because they are u values. You're going to put them in for u. All right? If you truly want to go back to x's, then you can go back to x's in here in place of the u, but then you need to go back to your 0 and pi over 2 because those are your x boundaries. So if you go back to x's, use your x boundaries. If you keep your u, use the u boundaries that you just found. So I get natural log of 3 minus natural log of 2. It's very unlikely that multiple choice would have that as an answer. What could they do with that? Well, they could use their log properties and make that natural log of 3 over 2. That would be the multiple choice answer. Okay? Okay, on to number 4. All right, number 4 is one that I really like. I will tell you that AP loves these integrals with e's in them. So I'm going to do my best to get you guys ready for integrals with e's in it because I know it's likely that you're going to see it on the AP exam. So when I look at this, here's my thought. If I let u be the entire bottom, when I take du, I'm going to get an e to the negative x. Do I have an e to the negative x? I do not. So you cannot just u sub the whole bottom. You have to do something else. We have to manipulate this. We have to make it so that there's an e upstairs in the top, in the numerator. Until we get an e upstairs, we're not going to be able to do a u sub. All right? So how can we get an e upstairs? Well, I'm going to be multiplying top and bottom by something, right? What do we want to multiply top and bottom by? Well, let's think about this. I could rewrite this as 1 over 1 plus, instead of having e to the negative x, what could I write for that? I could write 1 over e to the x, right? Then it might hopefully be more obvious what I'm going to multiply top and bottom by. I'm going to multiply top and bottom by e to the x. I'm still going to have that dx there. Okay? So if I do that, Upstairs now I have e to the x. Now we have to distribute this. E to the x times 1 is e to the x. E to the x times 1 over e to the x is 1. Okay? Now this is looking a lot better to me because I see, holy smoke, now I can let u be that, du will have an e to the x in it, and that's upstairs. It's waiting for me just like a Christmas present from Santa, right? So I'm going to let u be the e to the x plus 1. Du is just e to the x dx. And there's my e to the x dx waiting for me under the Christmas tree. So there's my du. Exactly. And now I have 1 over u du. Or du over u, which is natural log absolute value of u, and u is the e to the x plus 1. That would be the multiple choice answer as well. Okay? So, not bad. You just have to know what to do, and you have to be thinking, okay, I can't let u be that bottom yet. I have to get an e upstairs. How can I do that? So, there you go. All right, number 5. I'm looking at number 5, and I see a fraction. The degree of the top is 2. The degree of the bottom is 1. And when the top degree is greater than or equal to the bottom degree, we know all the time our first step is to divide. Every time. No exclusions, all right? So let's come off to the side and divide. I have 2x, and I'm dividing it into x squared plus 3. Okay. You know what? We are going to divide. I don't know why I wrote this. Since we just have a monomial down here, I'm not going to do this. I could do that, but I don't have to. I can just do this thing. Just divide that 2x into both the top and the bottom. Split this up into 2 fractions. If we split that up into 2 fractions, we're going to have x squared over 2x, which is 1/2 x, plus 3 over 2x. How could we write that? How about if we write it as 3/2 times 1 over x? Why would I write it like that? Well, I'm setting it up to do an integral, right? I'm setting it up to find the antiderivative. And I know the antiderivative of 1 over x. So for the same reason that I take out and make this a 1/2, I'm going to do the same thing here. Do you have to do it that way? No. But I like to do it that way. All right, now it's time to do the antiderivative. Antiderivative of 1/2 x, this is just power rule, raise the power by 1, divide by the new power. Over here, the antiderivative is 3/2 natural log absolute value x plus c. And that's it. All right, number 6. In number 6, again, the degree of the top is bigger than the degree of the bottom, or equal to, bigger or equal to. We go off to the side and divide. This is one where I can use synthetic division, so I will. If I can use synthetic division, I will, instead of long division. So positive 2 goes in the box. We write our coefficients of the numerator off here. So we have a 1 from the x cubed, a negative 3 from the x squared. There is no x term, so I write a 0 for that, and the 6. Remember, if you have an x cubed, you're going to have 4 terms here, 4 coefficients. 1 for the x cubed, 1 for the x squared, 1 for the x, and 1 for the constant. All right, bring down your first coefficient, multiply, and add. Multiply, and add, multiply, and add. We started with an x cubed and we divided out an x. So this will be an x squared right there. That's the coefficient of the x squared. This is the coefficient of x. This is our constant. And this is our remainder, which we always put over the divisor, the x minus 2, the denominator of our fraction. So we have now, we have not integrated, all we did was divide. We have not integrated yet. So we have x squared minus x minus 2 plus 2 over x minus 2 dx. Now we do the antiderivative. So x cubed times a third minus x squared times a half minus 2x plus 2 natural log absolute value x minus 2 plus c. Why can we go straight to the natural log of that bottom? We can do that because the derivative of this guy is 1. Whenever the derivative is 1, you can just go straight to your natural log. Okay? Usually in class, at this time, when I'm talking about that whole concept, I'll usually go grab a clean side of the board and I'll say, okay, let's do this. What if we have 1 over x dx? What is that? Natural log absolute value x plus c. Okay. What if we have 1 over x plus 7? Okay, that is just natural log absolute value x plus 7. Again, because the derivative is 1. Okay, what if we have integral 1 over 2x plus 3? Okay. Well, it's going to have a natural log 2x plus 3 in it. It's going to have that in it. But we are going to need to have something out in front, because when we take this derivative, the derivative is going to be a 2. The derivative is a 2 this time. And think of it this way. When you let u be that bottom, du is going to be 2 dx. In place of the dx, I'm going to need to put a 1/2 du. So there needs to be a 1/2 out here. So see, the derivative was 2, and we ended up with a 1/2 out in front. So then I would say, okay, so what would this be? Oops, I didn't mean to put an x here. How about, goodness, let me just do that. What if we have 3 minus 5x? Well, the derivative now is negative 5. So we're going to need a negative 1/5 natural log absolute value 3 minus 5x. Okay, and then I usually do this. What about this one? Okay, is this a natural log? Is this going to be natural log of x squared? No, it's not. If you let u be that, the derivative would be 2x. There's an x with it, so we would have to have an x upstairs if we were going to do that. This is not a natural log. We would write this as x to the negative 2 and use the power rule. If it's not a natural log, you use the power rule. Okay? X to the negative 1 plus c. Or negative 1 over x plus c. Okay? So I would usually do that in class on that day. All right, let's take a look at number 7. Okay? Well, number 7, I see an antiderivative of cosecant. Antiderivative of cosecant. I know the antiderivative of cosecant. It's not just cosecant x, though. It's cosecant of 2x. Okay, well, if u is 2x, then du is going to be 2 dx. So I'm letting u be the 2x. In place of the dx now, I can put 1/2 du, because 1/2 du is dx. So now my integral becomes 1/2 integral cosecant u du. I know that antiderivative. So for cosecant, It's going to be a negative natural log absolute value cosecant u plus cotangent u. That's something that you just have to know, you guys. You just need to know that. Put it in your memory banks. I don't remember that one. What I remember is, I remember the antiderivative of secant x. That's the one I remember. And I know that's natural log, absolute value, secant x plus tangent x plus c. So I remember that one, and then I quickly in my head can convert it to cosecant x, or u. Okay, but I do expect you to know that. Okay. All right. Number 8. What do we have here? We have a xe to the 3x squared. I'm going to do a little u sub. U is 3x squared. Du is 6x dx. Here's the x dx. So I'm going to leave that there. I'm going to divide the 6 over. I'm leaving the x dx because now I know I can substitute in place of that x dx. I'm putting 1/6 du. So my integral becomes integral 1/6 out in front, e to the u du. The integral of e to the u is e to the u. And lastly, back to x's. Okay. Number 9. Okay. 3 to the 4x, there's my u. U is 4x. Du is 4 dx. So in place of the dx, I'm going to need a 1/4 du, because when I bring the 4 over, I'll get dx alone. So I have 1/4 integral of 3 to the u du. Here's my thought process. For 3 to the u, I need a 3 to the u. And then I need to undo the natural log of 3, which comes with the derivative. So this will be 3 to the 4x divided by 4 ln 3 plus c. All right. Next up, in this review, I have a little Euler's method for us to do. Use Euler's method with 2 equal steps to approximate the value of f of 3.2 given the information in the table. All right. Well, for Euler's method, we always need a starting point. We always need a starting point, and we always need delta x. Always. What's our starting point? Well, we're only given one point here. We're only given the point 3, 2. So that must be our starting point. That's our only point that we're given. What is delta x here? Well, if we're going to go from 3 to 3.2 in 2 equal steps, delta x is going to have to be 0.1. Have to be. So in every Euler's method problem, be thinking that. I need my starting point and I need my delta x. Next up, sometimes they give us an equation for the slope, dy dx. Sometimes they'll give us that. In this case, they didn't give us the equation, they just gave us the answer for each derivative. So at 3, 2, the derivative is 0.5, right? Now we're setting up our point slope form. So y minus the y value is equal to the slope times x minus the x value, which is delta x. That's why you need delta x. This delta x will stay the same in both steps that we write. So y, if we put the 2 over, is 2 plus 0.5 times 0.1. Yes, I need you to do that. 0.5 times 0.1 is going to be a 5 with 2 decimal points in front of the 5, so 0.05. So our first stopping point after we go up 0.1 from 3 is approximately 2.05. And now we have our new point. And what is f prime at that point? Well, f prime at that point is this 0.3. So our slope at that point is a 0.3. Y minus the y value is equal to that slope times x minus the x value, which is delta x. Doesn't change. So y is going to equal 2.05 plus 0.3 times 0.1 is 0.03. So f at our next, going up from 3.1, going up 0.1 from 3.1 is 3.2, which is what we were trying to find, is approximately 2.08. And that's what we're trying to get to. We don't have to write them in the table. You can if you want to, but you don't have to write them there. Number 11 here. Number 11. It says consider the differential equation. Gave us a differential equation. And that's all they said. Consider that differential equation. Okay. On the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. And I'm looking over here for my little straight edge. There it is. Okay. All right. So let's see. At the point 0, 0. That's one of our points. So at the point 0, 0, I'm going to put 0 in for x, 0 in for y. I get -1. So the slope right there is a -1. So I do this, and I'm lining up my little straight edge with that point to get a nice -1 slope. Okay? And then I'm going to go on. So at the point 1, 0, 1, 0, so we'll have 1/2 minus 1. That's a -1/2. -1/2 is down 1 over 2, or up 1 to the left 2, correct? So -1/2 would be right there. Okay? Let's come get this one. Negative 1, that point is -1, 0. So -1/2 minus 1 would be a -3/2, right? So it would be down 3 over 2, or up 3 left 2. I think I'm going to do up 3 left 2, so I'm going to kind of eyeball this. There would be 1 over, there would be about 2 over, just to kind of get a nice approximate slope there. Okay? Now let's do 0, 1. 0, 1, so 0's in for x, 1's in for y. 1 minus 1 is 0, so that slope is 0. Okay, 1, 1. 1/2 plus 1 minus 1, so that'd be a positive 1/2. So up 1 over 2, or down 1 left 2. That'll be easier for me to line up, so that's the one I'm going to do. Oops. Yeah, that was positive 1/2. Thought I did a negative. Okay. -1 in for x, positive 1 in for y. So this will be 0, and we're going to have a -1/2 this time. So down 1 over 2. Down 1 over 2. Okay. 0, 2. 0, 2. I'll have 2 minus 1, which is 1. Positive 1. 1, 2. 1/2 plus 2 minus 1. So it's the 1/2 plus 1 is 3/2. So up 3 over 2, or down 3, right, left 2. So I'm going to do that one. Oops. 3/2. And then lastly, -1 would be a -1/2 plus 2 minus 1. So -1/2 plus 1 is a positive 1/2. So up 1 over 2, or down 1 over 2. I think I'm going to go up 1 over 2, about like that. Okay. When I'm grading this, I'm going to be looking like at your approximated slopes. I will definitely look at where you put a 0 slope or where you need to put a 0 slope, and then I'll look at your like -1s, and I will look at each line, okay, and make sure that they are accurate. But I'm not going to be getting out my protractor here and measuring everything. I won't be measuring, but I will be looking for general accuracy on that. Okay? All right, part B. Find the second derivative in terms of x and y, and then describe the region in the xy plane in which all solution curves to the differential equation are concave up. Okay, so first things first, and let's find the second derivative. So they gave me the first derivative. To find the second derivative, we take the derivative of both sides with respect to x. That's what the second derivative is. So we get the second derivative of y with respect to x is equal to, okay, 1/2 plus the derivative of y is 1, but we're taking it with respect to x. So it's 1 dy dx. You have to do that implicitly. And then the derivative of -1 is 0. So this is the second derivative, but it's not in terms of x and y yet. To get it in terms of x and y, we replace dy dx with what dy dx is. So the second derivative is going to be 1/2 plus 1/2 x plus y minus 1. That's in terms of x and y, so we are in good shape. That would be a safe spot. All right, next up we're going to describe the region in which all solution curves to the differential equation are concave up. Well, the curves are concave up when the second derivative is positive, correct? So the curves are concave up when 1/2 plus 1/2 x plus y minus 1 is positive. Did I describe the equations of the curves when the curves are concave up? Yeah, I did. Is it simplified? No. Do we have to simplify? No, we don't. That's sufficient. So we're good. All right. Part C. Let y equals f of x be a particular solution to the differential equation with initial condition f of 0 is 1. Does f have a relative min, max, or neither when x is 0? Justify your answer. Okay, are they asking us to find the particular solution? Do we have to solve this differential equation? No, they're not asking us to find it. They're just asking us, does it, I know it exists, does it have a relative min, max, or neither? Okay? Don't try to find it. In fact, if you try to find it, you're going to be spinning your wheels. You know why? This is not a separable differential equation. So we don't know how to solve this. Okay? This is one that you will be solving when you take differential equations in college. We don't do it in Calculus BC. All right? They don't do that in Calc 1 or 2 or 3 in college. That'll be in differential equations. Okay? So don't try to solve it. If you don't have to solve it, don't try to solve it. Okay? All right. They're asking us, does f have a relative min, max, or neither at x equals 0? Well, if I'm being asked something about relative min, max, I know I can either use the first derivative test for relative extrema or the second derivative test for relative extrema. I just found the second derivative. So I think I'm going to be using that test. Either way, we start the same. We find the first derivative when x is 0, right? Well, that is dy dx when x is 0. And when x is 0, y is 1. Why do I need that? Because our dy dx has a y in it also. So I'm going to be putting 0 in for x and 1 in for y. So that is 1/2 plus 1/2 times 0. That's 0 plus 1 minus 1, right? So I just plugged in 0 in for x and 1 in for y. So that is 0. That means at x equals 0, the slope is 0. So maybe it's a min, maybe it's a max, maybe it's neither. What if we had not gotten 0 there? If we had not gotten 0 there, immediately the answer would be neither a min nor a max. Because the slope has to be 0 or undefined for there to be a relative min or max. Okay? So since I got the slope to be 0, now I'm going to go to the second derivative. Okay, what is the second derivative at that point? Well, there's my equation for the second derivative. So I have 1/2 plus 1/2 times 0, I keep writing that, plus 1 minus 1. What is that? Well, that is 1/2, which is positive. That means at x equals 0, our curve is concave up. So f is concave up, right? Well, if we're concave up and we have a 0 slope, what does that mean happening? Concave up and a 0 slope means that we have a relative minimum. So I'll say, so f has a relative minimum when x is 0. Okay? It says to justify. The justification is right here. If you really want to, you can say since f prime of 0 equals 0 and f double prime at 0 is positive. Okay? All right, part D. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. Okay? I've got this from an old AP exam, and this is a little bit of a tricky question, all right? Well, here's what I'm going to do. I know if this is a solution, then y prime has got to be this. If this is a solution, then dy dx has got to be that, right? So here's what they're saying is a solution. So that means dy dx has got to be, what is the derivative of this with respect to x? It's just m. That has got to be equal to dy dx up here, if it's a solution. Okay? Now I'm going to take this guy, I'm going to solve it for y. Take this and solve it for y. So it's going to be ym plus 1 minus 1/2 x is equal to y, right? Or I could say y is equal to negative 1/2 x plus m plus 1, right? Well, now let's look at this. Y equals mx plus b is sitting right there. And look at our equation. It's in the exact same form. Now I know m has got to be a negative 1/2. Got to be. B has got to be m plus 1. So therefore b is a half. That's how you do that problem. Let's look at how they would score this. Let's look at how they might score this. I didn't write down how they scored this originally. But let's take a look at this. In part 1, I know that you would get a point for finding the second derivative. I know they would. And then they would probably just give this another point for describing the region where the curves are concave up. Okay, so that would probably be worth 2 points on AP. On our tests that we give in class, I usually double their points, so that would be worth 4 points instead of 2. Okay, part C. Let's see. I can see this. Oh, I'm sorry, I skipped right over part A. Well, you know what? I'm going to save part A because I'm going to see how many points I have left over. But usually, if you found 9 points, the slope's at 9 points, it's probably going to be worth 2 to 3 points. Okay, and maybe they would do it by rows or by columns. I don't know, but they would split it up somehow. Okay, part C. I know that you would get a point, you would likely get a point for finding f prime at 0 or dy dx at the point 0, 1. You'd get a point there. Okay, and then I'm looking at how many points I've allocated so far, and already I've done 5 for that, 6. Probably just another point for your answer with justification. Sometimes they say answer with justification. And then this would probably be worth 2 points. Probably 1 point for finding dy dx is equal to m, and then 1 point for your answer. So a total of 9 points. Every FRQ, 9 points. Okay, let's see what part number 12 looks like. Number 12, we have consider the differential equation. They gave us another differential equation. We start with sketching a slope field. And again, we have 12 points. Okay. 12 points here. So let's see. When x is 0, oh, this is nice because when x is 0, and x is 0 at 3 of these points, when x is 0, I'm sorry, x is 0 at 4 of these points. Well, that's not bad at all. When x is 0, dy dx is 0, right? So that's going to be nice to put that. Now here's a word of warning. When you are drawing with your pencil, when you're writing a slope field with your pencil, I cannot see it if you go right over the axis and you write really lightly. I won't be able to see it. And if I can't see it, I'm not going to assume it's there, all right? So my best advice is to tell you to go slightly above the x-axis so that I can see that 0 slope there, all right? And I'm going to come and grab these other 0 slopes. Okay, let's go to the point 1, 0. 1, 0. 1 times negative 2 is a negative 2, right? So down 2 over 1 or up 2 left 1. I'm going to go up 2 left 1. There's my negative 2 slope. Let's go to the point 1, 1. For 1, 1, I have 1 times a negative 1, so that is a negative 1. So again, down 1, right 1, or up 1, left 1. Negative 1 slope. Okay, 1, 2. Well, anytime y is 2, I'm going to have a 0 slope. So right here where y is 2, I'm going to have a 0 slope. Both of those. I can knock those out right there. 1, 3. 1 times 1 is 1. Up 1 over 1, or down 1 left 1. There's my 1 slope. Negative 1, 0. Negative 1, 0 is negative 1 times a negative 2. That's a positive 2. So up 2 over 1, like that. Negative 1, 1 is going to be a positive 1. Did I do that right? Ooh, I don't think I did that right. I didn't do this one right. And now I'm wishing I had these erasable pens. I didn't do that one right. So I need it to be a negative 1 to the fourth is 1 times a negative 2 will still be a negative 2. So I want this to be a negative 2. So down 2 over 1 or up to left 1. So I'm going to make this stand out so that whoever's grading it knows, and maybe I'll put here -2 slope, okay, so that whoever's grading it knows, and who's grading it, I'm trying to help myself out here when I'm grading your papers, if you make a mistake and you've written in pen, make it clear what the answer should be, okay? Don't make the grader guess. They will not just give you the benefit of the doubt. If they can't grade it, they can't grade it. If I can't read it, I can't read it. And that being said, you guys, when you submit your tests in Schoology for me to grade, if I can't read it, I can't grade it, all right? So you're going to get a 0 on things if I can't read it. So please don't do that. All right, let's continue. -1 to the fourth is 1 times -1 is a -1. So we got a little -1 slope. And then -1, that's going to be a +1 out front after we raise it to the fourth power, times 3 minus 2 is going to be a +1. Somewhere around here. Okay. All right, and now it says, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Well, that's true. Even though we only drew it for 12 points, it is defined everywhere because there's not an x or a y in a denominator or under a square root that's going to make it undefined. Okay? Describe all the points in the xy plane for which the slopes are negative. So we want to describe the points for which the slopes are negative. Well, this is our dy dx, right? X is always being raised to the fourth power. So that piece is always positive. So the only aspect, the only part of the point that could possibly make it negative is the y value. Okay? And the slope is negative when that piece is negative, correct? Well, that piece is negative when y is less than 2. So the slopes are negative when y is less than 2 and x is not 0. Why? Because if x is 0, the slope is going to be 0. So y has to be less than 2 and x cannot be 0. Does that make sense for the points that we drew? When x is less than 2 and not 0, when y is less than 2 and x is not 0, do we have negative slopes? Yeah, we do. So very good. And then part C, find the particular solution to the given differential equation with initial condition f of 0 is 0. All right. When you see find the particular solution, you should be thinking big points. This is going to be worth a lot. So take your time and do it right. We have our differential equation. Okay, step 1, separate. Step 2, integrate. Separate, then integrate. every time you're finding the particular solution, every time you're solving a differential equation that is separable. Separate and then integrate. So first we're going to separate by dividing both sides by y minus 2. And we're going to multiply both sides by the dx. So we have successfully separated. Now we integrate. Okay, the antiderivative of 1 over y minus 2 dy is natural log absolute value y minus 2. Do we need a coefficient out front? No, because the derivative of this is just 1. The antiderivative of x squared is x cubed times 1/3, power rule. Don't forget your plus c. Okay? Now I'm going to raise both sides. I'm going to take e to both sides. E to both sides, right? When I e to both sides, on the left, I have y minus 2. It would still have the absolute value bars on it, but I'm about to get to lose them. So I'm just going to write it without it. Okay? Here, e to the 1/3 x cubed plus c is a constant times e to the 1/3 x cubed. This constant is not the same constant as this c. But that's okay. We're just about to find a new constant. Okay? If you don't know why that's true, let me come off to the side. Let me come off to this scratch piece of paper again. If you don't know why that's true. We have e to the 1/3 x cubed plus c. Okay? Well, I know my rules of exponents, and I know that I can break this up into e to the 1/3 x cubed times e to the c. That's just a rule of exponents. And if you don't believe it, what's x squared times x to the 4th? Isn't that x to the 6th? How did you get the how did you get the 6? Well, you added the 2 plus 4. If you have 2 plus 4 here, it's the same as x squared times x to the 4th. So if you have e to the 1/3 x cubed plus c, it's the same as e to the 1/3 x cubed times e to the c. Now, e to the c is just another constant. So I can take it and put it up in front and call it just c. It's just another constant, which can be positive or negative depending on which particular solution I have. That's why we can lose the absolute value bars. This is going to take care of my positive or negative. All right, now we're going to find c. So I'm plugging in my point that I'm given. 0 in for y, 0 in for x. E to the 0 is just 1, so negative 2 is equal to c. Now I have y minus 2 is equal to negative 2 e to the 1/3 x cubed. Last step, move your 2 over. And that's it. These are worth big points. Let me talk about what points would be earned here. 1 point for separating. I would give 2 points on my test. AP gives 1 point for separating. 1 point for the correct antiderivatives on AP. I would give it with, I always double, so I would do that for 2 points. Sometimes on AP, they give 1 point for each antiderivative. Okay? The next point is for finding c using your initial condition. And then the last point is solving for y. Okay? At least 4 points, maybe 5, depending on the problem. Okay? Let's see, how else would they score this? Looking at the problem, I actually can see them making this worth 5. Because for the problem, this would be at most 3 points. Okay? And there wasn't just a whole lot to break things down here. really wasn't a whole lot to break things down. I can see this be worth 2 points maybe. I can also see it worth 1 point. But if it's like this, that I'm adding up to 9 points here, so maybe that's how they would score this. Okay, so that is my in-class review. Join me on Zoom for tutoring if you have questions.